Hi guys, I am Steven from Aero department. Today I am here about the concept video. The topic is about normal form. Okay, let's we go into the normal form. The normal form of a matrix A is a matrix of a pre-assigned special form obtained from A by means of transformations of a prescribed type. One distinguishes various normal forms depending on the type of transformation in question on the domain K, 2 while coefficients of A belong on the form of A, and finally on the specific nature of the problem to be solved. For example, on the desirability of extending or not extending K on transition from A to N, on the necessity of determining N from A uniquely or with a certain amount of arbitrariness. Frequently, instead of normal form, one uses the canonical form of a matrix canonical form. On the necessity determining N from A, among the classical normal forms are the following: hence, fourth capital M small m into n of capital K denotes the set of all matrices of m rows and n columns with coefficients in K. What Let's we go into the normal form. What is normal form and how it is useful to, and how we will use it. Normal form. Normal form of a matrix is a matrix satisfying following conditions. There are three conditions for normal forms to satisfy the matrix. First one consists of only ones and zeros. In this normal form, there is only consists ones and zeros only. And we will go into the second point. Every row has a maximum of single one and rest are all zeros. There can be rows with all zeros. And we will go into the third point. Every column has not more than single one. The normal form of a matrix is obtained from its original matrix by undergoing transformations on the rows and columns. The transformations include multiplying a row with a certain integer and subtracting the values of the row from another row and placing the result in its previous place. Converts the given matrix into its normal form and find its rank. The transformations will take place on the rows and columns and including multiplying a row with a certain integer and subtracting the values and one row from the another row. For example, we are given a matrix A where A is equal to 1, 2, 3 and second row 2, 4, 6 and third row 4, 8, 12, and we have to find its rank using its normal form. First we have to find the rank, and the matrix A has 3 rows and 3 columns. There is 3 rows and 3 columns. Rows are R1 and R2, R3 are the 3 rows, and C1, C2, C3 are the 3 columns. Convert the matrix A into its normal form by transformations. By transforming the matrix with rows and columns, we will go into the first transformations with rows. Is R3 is equal to R3 minus 4R1, which means transforming the third row by subtracting 4 times of first row from third row. Here we are subtracting the third row with fourth row of 4 times of first row. R3 minus 4R1 is equal to 4 comma 8 comma 12 minus 4 of 1 comma 2 comma 3 is equal to 4 comma 8 comma 12 minus 4 comma 8 comma 12. Here R3 minus 4R1. Here 0 0 0 is the first transformation answer. Replace the result in the place of third row, and A is equal to here 1 2 3, and second row is 2 4 6, and third row is becoming zeros. And we will go into the second transformation with R2. R2 is equal to R2 minus 2R1, which means transforming the second row by subtracting 2 times of first row from second row. Here we are subtracting the second row with 2 times, and the result is R2 minus 2R1 is equal to 2 comma 4 comma 6 minus 2 into 1 comma 2 comma 3. Here 2 comma 4 comma 6 minus 2 comma 4 comma 6, and here the result is R2 minus 2R1 is equal to 0 0 0. In R2 also there is zeros. Replace the result in the place of the second row, and it will become here A is equal to 1 comma 2 comma 1 2 3 and 0 0 0, and third row is 0 0 0, and here rank of a matrix can be told as a number of non-zeros in its normal form. Here there is only one no zero row, therefore rank of the matrix A is equal to 1 2 3 2 4 6 4 8 12 is 1. Here rank of the matrix is 1. In the normal form of a matrix, every row can have a maximum of a single one, and rest are all zeros. There can also be rows with all zeros. Rank of the matrix can be found from its normal form by counting the number of non-zeros rows. A normal form is also known as canonical form or standard form. A normal form is doing rows and columns operations. We will do row operations and column operations by step, and we will get the answer. Thank you for giving this opportunity.